All right, we're continuing the Unit 4 review, and this question, number 7, says solve the following equations by graphing. Okay, so these are equations, not inequalities. So these are going to be lines, and we're going to graph them on the graph paper here, and then find where they intersect, and that'll be our solution. And it does say solve, so we have to write the solution at the end. Now, in order to graph these lines, we've got to get y by itself. We have to get it in y equals form or slope-intercept form. Right now, they are in standard form. So we're going to take the first equation, 2x plus y equals 6. And to get it in slope-intercept form, or to solve for y, we need to subtract the 2x from both sides. And then we get y equals, I'm going to write the negative 2x first because that is my slope. So negative 2x, and then plus 6 because that's a positive 6. So now we're ready to graph this line. For the slope, I'm going to put a 1 underneath. And then I'm going to start with the y-intercept, the 6. 1, 2, 3, 4, 5, 6. Then I'm going to go down to right 1. Down to right 1. Right, and now this is a line. It's not an inequality, so I don't have to worry about whether it's solid or dotted. I'm just drawing a line here through these points. Right, and then I'm going to draw the other line and see where it intersects. So I need to do 3x minus 3y equals 9. And I'm solving for y again, so I'm going to subtract 3x from both sides of the equation. So I have negative 3y equals, I'm going to write the negative 3x first, plus 9. And then divide by negative 3. So y equals x. And then 9 divided by, negative 3 divided by negative 3 is a 1, so that's 1x. And then 9 divided by negative 3 is negative 3. And if I want to write a slope here, I would put 1 over 1. And then I'm going to start at negative 3 on the y-axis, for my y-intercept, and then go up 1 over 1. Up 1 over 1. Draw a line through these points. The intersection where the lines cross is this point right here, which is 3, 0. So my solution is 3, 0, and I've got to write this down and indicate that it is the solution. Okay, number 8 says solve the following systems of equations by an appropriate method. Right, so that means that you can use any of the 4 methods: graphing, substitution, elimination, or matrices. If you like matrices, these are all ready to go. They're both in standard form, and you can put that in your calculator. I'm going to go ahead and do elimination, just so that we can review what elimination is. So I'm going to multiply the bottom by 2. That way I can eliminate the 4 x's, or the x's. So 2 times negative 2x would be negative 4x. 2 times 3y would be 6y. 2 times 16 would be 32. And I eliminate the x's, and I add negative 2y and positive 6y and get 4y, and 16 and 32 is 48. Then I'm going to divide by 4 to solve for y, and y is 12. And then I'm going to plug the 12 back in to either one of these equations. So I think I'll just do the top one. So 4x minus 2, and then in place of the place of the y, I'll put a 12, equals 16. So 4x minus 2 times 12 is 24, equals 16. And I'm solving for x, so I'm going to add 24 to both sides of the equation and get 4x equals 40. And then divide by 4, and x equals 40 divided by 4 is 10. So my answer is 10, 12, or I can write x equals 10 and y equals 12. All right, number 9. Solve the following system of equations below by using the appropriate method. So I can use any method I want again. And I think this time I'm going to use elimination again. Actually, because I've already done some matrices on numbers 1 through 6. So we'll go ahead and do elimination again. So I'm going to keep the top one just like it is. X minus 7, y equals 14. And I'm going to multiply the bottom one by negative 1. So negative x minus 2y equals negative 5. Cancel out the x's. That gives me a negative 9y equals 9. 14 minus 5 is 9. And then divide by negative 9, and y equals negative 1. So that is my first answer. Then I'm going to plug negative 1 back into one of these. So I'm going to plug it into I'm going to do it in the second one this time. So x plus 2 times negative 1 equals 14. So x plus 2 times negative 1 is negative 2. So I'm going to have x minus 2 equals 14. Then I'm going to add 2. Whoops, I just wrote that down wrong. Actually, that's a 5, isn't it? X plus 2 times negative 1 equals 5, not 14. Okay, then I'm going to add 2 to both sides, and so now I get x equals 7, which is the right answer. So the answer is 7 comma negative 1. Now you could also put that straight into matrices, and you could check it. You could do it one way, like this, and then check it using matrices, however you want to do it. Okay, now number 10, we're going to solve the following inequalities below by graphing. All right, now these are inequalities, so I'm not graphing these as lines and finding where their intersection is. What I'm doing is graphing these as lines and shading and finding where the shading intersects. So I'm going to take 5x plus 4y is less than or equal to 20, and I'm going to solve for y. So I'm going to subtract 5x. I have to get this in slope-intercept form, and have 4y is less than or equal to, I'm going to write my x first, negative 5x plus 20, so I can have it in slope-intercept form. I still don't have y by itself. I need to divide by 4, and I have to divide everything by 4. So y is less than or equal to, and I'm going to leave this as a fraction because this is my slope, negative 5x over 4, or negative 5/4 x would be probably a better way to say that, plus 20 divided by 4 is 5. So I'm going to go ahead and graph that, and 1, 2, 3, 4, 5 is my y-intercept, and then I'm going to go down 5, right 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. And it has an equals, which means that I'm going to draw a solid line, not a dotted line, but a solid line. It's less than, so I'm going to shade below. So for right now, I'm just going to draw the arrows showing that this shades below. All right, then I'm going to do the same thing with the bottom equation or inequality. 3x plus 6y is less than 18. I'm going to solve for y, so I'm going to subtract 3x from both sides. 6y is less than negative 3x plus 18. Then I'm going to divide everything by 6 so I can get the y by itself. So y is less than, and I can reduce the negative 3/6 to negative 1/2 x plus 18 divided by 6 is 3. Now you don't have to reduce that. You could leave it as negative 3/6 and you would still be able to graph it. But I went ahead and reduce it to 1/2. So I'm going to start at positive 3. Then I'm going to go down 1 and right 2. I always use the negative to go down and then make the bottom one positive. So down 1, right 2, down 1, right 2, down 1, right 2, or up 1, left 2. Okay, this does not have an equals, so I'm going to make a dotted line for this one. This is also less than, so that means that the arrows are pointing down. We're shading below. All right, and the part where the arrows intersect would be this part here, this entire area underneath. Okay, so this is the border for this part, and then it goes here. Okay, number 8, and this is my solution. Where the shading intersects is how you solve it. That is a solution to an inequality. Right, number 11, I'm thinking of two numbers whose sum is 12 and whose difference is 4. Let x be the first number and y be the second number. Write a system of equations that can be used to solve this problem. So if x is the first number and y is the second number, then I can write two equations with x and y. The first one would be, I'm thinking of two numbers whose sum is 12. So sum means that I'm going to add the two numbers together. So x plus y equals 12. And then whose difference is 4. So it's the same two numbers, but difference means subtract. So instead of x plus y, I'm going to have x minus y equals 4. And it doesn't say that we have to solve it. So this would be our answer right here. Okay, number 12. Two numbers have a sum of 130. Twice the larger number is 15 more than 3 times the smaller number. Set up a system of equations and solve for the two numbers. So we've got a larger number and a smaller number. I'm going to let x be the larger and y equal the smaller, and you have to tell me which one you have picked to be your smaller and your larger. And then two numbers have a sum of 130. So x plus y equals 130. Sum means to add. And then twice the larger number, so that would be 2x, because x is my larger number, that's equals 15 more than means I'm going to put plus 15 out here, 3 times the smaller number, which would be 3 times y. Okay, so there are my two equations, and it says that I have to solve. All right, so on this one, what I'm going to do is bring the 3y over to this side. So I'm going to keep the top one like it is, x plus y equals 130. And then I'm going to subtract 3y from both sides down here. So I'll have 2x minus 3y equals 15. Now I could use elimination, or I could use substitution. I can get x by itself and do x equals 130 minus y, or I can use matrices. So I set this up where they both be in standard form, so I can use matrices. And so I'm going to put the matrix in here as 1, 1, 130, 2, negative 3, 15. Okay, so we'll put it side by side like this. So second matrix, edit, and this is a 2 by 3. And I'm going to put 1, enter, 1, enter, 130, enter, 2, enter, negative 3, enter, 15, enter. Now I'll do second, quit, second matrix, math, RREF, then second matrix, enter A, and I get diagonal ones, which tells me that this is probably correct, and I've got 81 and 49. And since I put x first, x equals 81, y is second, y equals 49, which makes sense because I said that x was my larger number, so x is 81 and y is 49, which is the smaller number. Now you could have done this with elimination or however you want to do that. You did not have to use matrices. Okay, 13. If a system of two linear equations had no solutions, what would the graph look like? So no solutions means the graph of the equations would never intersect. So there would be two parallel lines. So that would be parallel lines. All right, and then 14. What is the first step you might take in solving this system by elimination? So it doesn't ask you to solve it. It just said what would be the first step you could take. So the easiest thing to do in this case would be to multiply the top one by negative 3. And then I would have a negative 3y here. So the answer would be multiply the top equation by negative 3. And that would do, all we have to write down is our first step. Okay, then in problem 15, what is the first step you might take in solving the system by substitution? All right, so this time we have to do substitution. And in substitution, what we want to do first is get one of the variables by itself in one of the equations. And so the easiest one would be the one that doesn't have a number in front, that only has a 1 in front of it. And so we're going to solve for y and get y by itself. So the way to solve for y is you would subtract 2x from both sides. So what we're going to put here is solve for y in the top equation by subtracting 2x from both sides. Okay, so solve for y in the top equation by subtracting 2x from both sides. And then if you were continuing on with substitution, then you would substitute 6 minus 2x in for y. Okay, but we don't have to do that. We just have to tell what the first step would be. All right, then number 16 is our last one. The first of two numbers plus 3 times a second number is more than negative 3. 4 times the first number minus the second number is at least negative 4. Using x as the first and y as the second number, set up a system of inequalities and locate all possible solutions for x and y graphically. When it says locate all possible solutions for x and y graphically, they're saying find where the shading intersects. And that shaded part will be the solutions. Okay, so we're going to write two equations. We've got two numbers, the first number and the second number. So I'm going to let x be the first number. Y is going to equal the second number. And I'm going to write this just like it says. The first of two numbers. So the first number, which is x, plus 3 times a second number. So 3 times the second number is y, is more than. Now, is more than means greater than negative 3. And it can't be equal to. It has to be more than negative 3. So that's our first equation. Then the next equation says 4 times the first number. So that would be 4 times x. Minus the second number, which is y, is at least negative 4. So that means it has to be negative 4 or more, or greater than negative 4. It can't be less than negative 4. So this would be greater than or equal to negative 4. It can be negative 4, and it can be anything above negative 4. Right, then we have to graph these. So we're going to have to solve for x and y, or solve for y in both of these. So on the first one, I'm going to write that down. X plus 3y is greater than negative 3. Then I'm going to subtract x from both sides. And so now I have 3y is greater than, I'm going to put the negative x first, negative x minus 3. Then I'm going to divide everything by 3. So y is greater than, and that would be like a 1 is an understood 1 right here, so negative 1/3 x. Then negative 3 divided by 3 is minus 1. Then I'm going to go ahead and graph this. So I'm going to start at negative 1. And this means I'm going to go down 1, right 3. And I can go backwards. I can go up 1, left 3. And it does not have an equal sign. So this is going to be a dotted line. Okay, and then I'm going to graph, I'm going to get the 4x minus y is greater than or equal to negative 4. I'm going to solve for y in that one and graph it. So 4x minus y is greater than or equal to negative 4. I'm going to subtract 4x from both sides. So negative y is greater than or equal to negative 4x minus 4. Then I'm going to divide everything by negative 1 to get rid of this negative. And so I have y, and because I divided by a negative, I have to flip the sign to less than. So now it's less than or equal to, and negative 4 divided by negative 1 is 4. And negative 4 divided by negative 1 is 4 again, so it's 4x plus 4. All right, then I'm going to graph this one, so I count up 1, 2, 3, 4 on the y-axis for this 4 right here. And then I'm going to put a 1 under this one, so that means I'm going to go up 4 over 1. So up 4, 1, 2, 3, 4, right 1. And that can go the other direction, down 4, left 1. And this does have an equals down here. So I am going to draw a solid line. Okay, and it says less than for this one. All right, and sometimes when they're this tall like this, or almost vertical, it's hard to tell which way is less than. But if you draw feet and a head on your graph, and less than means you are going to shade towards the feet. Okay, and then I forgot to shade this one. This one's greater than, so that means I'm going to shade towards the head. Or I'm going to shade above. Okay, so the place where these two are pointing is this section right here. Right, and that's the end of the review.